Good morning, all of you. In today's session, we are going to continue with the CSIR NET JRF Chemical Science December 2019 Part C question paper. So it is series 6. In each series, 10 questions of Part C will be given. Entire Part C will be covered. So this is the last series where question number 51 to 60 will be covered in this session. Part C consists of physical, inorganic, organic, all the sessions. So we are going to cover the series 6 where all 10 questions will be detailed, in detail explained. So let us move on to our actual question paper, where question number 51 of December 2019 CSIR JRF net question paper consisting the correct order of metal carbon bond distance is. In order to predict this correct order of bond distance, first we have to check what kind of complexes are given. All these are the complexes of transition metals. Here iron, cobalt, nickel complexes are provided, right? And in each complex we have same kind of ligand, that is neta 5 Cp taken twice. Neta 5 stands for each Cp group is providing 5 electrons, right? So 5 electrons are contributed by each Cp cyclopentadienyl anion, right? So 2 Cp, nothing but 10 electrons are given by this ligand, and in each complex we have the same kind of ligand. So this metal carbon bond distance mainly depends upon number of unpaired electrons which are present in the given complex. Let us find out number of possible electrons. Subsequently, it is possible to deduce metal carbon bond distances. In order to get that, we have the relation metal carbon bond distance increases by increasing number of unpaired electrons. Based on this statement only, we are going to predict which compound is having larger metal carbon bond distance. In order to get that, first let us look at into nickel Cp taken twice. Bis cyclopentadienyl nickel complex will be taken, right? This complex, central nickel is composed of Ns2 N-1 D8 system. Total valency electrons will be 10, and each Cp is contributing 5 electrons. We have 2 Cp groups, total 10 electrons are given. So total valency electrons of this complex will be 20. When we subtract this 20 with 12, the total possible valency electrons will be 8. So 8 will be there. So 12 electrons contributed by ligands. Okay. Now let us see CO Cp taken twice. This is the formula. So 20 minus 12 is equal to 8. Number of unpaired electrons in the nickel complex will be 8. So when we consider the second complex, cobalt Cp taken twice. Cobalt is of Ns2 N-1 D7 system. Means 7 electrons resided in d orbital. 2 electrons are present in the s orbital. 7 plus 2 total 9 electrons contributed by cobalt, whereas Cp is contributing 10 electrons. 10 plus 9, 19 electrons total valency electron count of this cobalt complex. Now subtract 12 from this, so that 19 minus 12 total valency electron, total unpaired electrons in this complex will be 7. Now let us see, let us calculate total unpaired electrons in iron complex. Iron is Ns2 N-1 D6 system. Whenever this complex is taken, iron is consisting 8 electrons in its valency shell, and each Cp is contributing 5, total 2 Cp, so 10 electrons given by Cp. So 10 plus 8 total 18 electron system. 18 valency electrons will be there in this iron Cp2. Now it will be subtracted with 12, so that total unpaired electrons will be 6. So greater the number of unpaired electrons, greater will be the nickel carbon bond length. So nickel carbon bond length will be metal carbon bond length. Metal carbon bond length will be greater in nickel complex, followed by cobalt, followed by iron. This is purely based on total unpaired electrons which are present in the given complex. That's the reason why nickel followed by cobalt followed by iron. Nickel followed by cobalt followed by iron. Option number 4 is the right answer for question number 51. Let us move on to question number 52, where we have long chain carbon where ketonic and ester groups are provided, and it should be treated with titanium trichloride in the presence of lithium aluminum hydride, followed by hydrolysis will be carried under acidic conditions. Let us see what will be the product. In order to get this, first we have to treat the compound with titanium trichloride. Titanium trichloride, when treated, it involved in ring cyclization. Ring cyclization will be carried, and followed by there is a generation of homolytic fission and concerted under concerted mechanism. Here two free radical carbons are generated. They get combined to give bicyclic ring. This bicyclic ring will involve in homolytic fission one more time, and the titanium dioxide will be discarded and forming here carbon-carbon double bond. This carbon-carbon double bond further can be tautomerized by ketoenol tautomerization under acidic hydrolysis process. Ketoenol tautomerism will be followed so that it is converted into double bond move. So how many 6 carbon, 7, 8, 9, 10, 10 carbon system it is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon system resided with ketone group, and adjacent position is substituted by methyl. 10 carbon decalin system it is. So it will be clearly given in the option number 2. For this question number 52, the exact answer will be option number 2. Right? So this is about 52. Now let us move on to question number 53, where the major product formed in the following reaction. We have to deduce what will be the product in this reaction. It is a kind of phenol, para-ethyl substituted phenol. It treated with chloroform in the presence of potassium hydroxide. So it is a characteristic reaction of aldehyde synthesis, which is called a Riemann-Tiemann reaction. Chloroform and combination with potassium hydroxide is generally generates aldehyde group at ortho position with respect to hydroxy. So here aldehyde group will be generated at ortho position. Anyway, para position blocked by ethyl, there is no option for para substitution. And in general, always Riemann-Tiemann reaction will be generating aldehyde at ortho rather than para because of intermolecular hydrogen bond formation. That's why aldehyde will be generated at ortho position. And second reagent will be hydrogen peroxide in the presence of alkaline medium, so that it will be oxidized aldehyde further converted into hydroxy. So option number 1 is the correct answer for this question number 53. Let us see the exact mechanism. In order to get the mechanism, in the presence of potassium hydroxide, this chloroform able to remove H plus and Cl minus, so that it is converted into dichlorocarbene. What is the intermediate in Riemann-Tiemann reaction? Dichlorocarbene is the intermediate. This dichlorocarbene binds to ortho position and it is converted into dichlorocarbon containing compound. And further protonation, dichlorocarbon will be attached to it this ortho position. Now it further subjected to hydrolysis. Chloro groups now replaced with hydroxy functional groups. Carbon retaining 2 hydroxy and the same carbon atom is highly unstable because of electron repulsions. That's the reason why it immediately involved in dehydration, so that aldehyde formation is possible. So whenever aldehyde generated, this is called a Riemann-Tiemann reaction. Till this, it is called a Riemann-Tiemann. Now, another named reaction we are performing in the presence of hydrogen peroxide and sodium hydroxide. This is called a Dichine reaction. Whenever Dichine reaction is performed, this hydroxyl, what we can say, hydrogen peroxide containing oxygen minus will be attached to carbonylic center, and followed by this insertion of oxygen in between carbon and phenyl ring will be possible, and subsequent hydrolysis leads to form OH. Simply hydrogen peroxide used to replace aldehyde with hydroxy. That is called a Dichine reaction. So by this we will get vicinal dihydroxy compound. Option number 1 only contains such a kind of functional group. And the correct answer will be option number 1 for question number 53. Now, let us move on to question number 54. In question number 54, the order of surface catalyzed unimolecular reaction at very low and very high pressure of reactant would be respectively. So it is a part of surface chemistry where we have to apply Longmuir adsorption isotherm. Whenever Longmuir adsorption isotherm is employed, we have to change the variable, that is pressure. So high pressure conditions as well as low pressure conditions can be applied. So under that conditions, what will be the reaction order? Rate of the reaction we have to measure. So in order to get that, we are taking the surface and treated with the molecules which are accumulated only on the surface, then only it is called adsorption. Always, Longmuir adsorption is the chemical process and monolayer adsorption is possible rather than multi-layer adsorption, right? And it is given by the formula theta is equal to Kp by 1 plus Kp. It is called Longmuir adsorption isotherm. A rate of the reaction is equal to Kp by 1 plus Kp. When pressure is low, entire denominator term is taken as 1 because pressure term is low, and when the pressure is present at denominator, that entire thing becomes 1 only, right? So now the rate is directly proportional to Kp, which is present at topmost position. Hence we can say order of the reaction will be only 1. So for this low pressure conditions, order will be first order. Now let us employ high pressure conditions. Under high pressure conditions, Kp will be greater than 1. When Kp will be greater than 1, Kp by Kp becomes 1. There is no parameter in order to predict the rate of the reaction. That's the reason why here rate of the reaction becomes 0. It is a part of zero order reaction. Low pressure is the first order, whereas high pressure will be the zero order reaction. 1, 0 is the right answer for question number 54. Option number 2 will be the right answer. Question number 55. The major product formed in the following reaction. What kind of product is formed? We have to predict that. We are taking phthalimide compound and it is in contact with the cyclic lactone, right? And treated with HBr, methanol, MEP, OET taken twice, and further hydrolysis under acid conditions. What will be the product? Okay. So it is clearly observed that when we see the final product should be alpha amino acid, because nitrogen, carboxylic acid both are on the alpha position with respect to each other. So when we observe first compound having alpha amino acid, second also having alpha amino acid, third alpha amino acid is not there, if we can discard this. Fourth also not there, we can discard. There is a probability of option number 1 or option number 2. Let us see the mechanism. When this compound, initial compound, phthalimide compound was taken, it is treated with bromide. So this used to open the ring system so that one side it is converted into COH, another side bromine will be generated, and it is treated with the methanol. So here carboxylic acid get converted into ester, methyl acetate, methyl carboxylate will be formed. Now it is treated with MEP, OET taken twice. In either center which having bromo can be replaced with this CH2P, OET, OET, CH3. This will be generated at this position. Later, subjected to hydrolysis. Whenever it's subjected to hydrolysis, clearly, phthalimide ring will be opened and both sides hydrolysis will be carried. Ultimately, it is converted into NH2, right? NH2 will be generated. The correct answer will be alpha amino acid having CH2, CH2P double bond with CH3, OH. That will be option number 2. So option number 2 is the right answer for this one. It is a kind of deprotection of alpha amino acids, right? For question number 55, option number 2 is the right answer. Question number 56, we are going to discuss now. The electronic spectrum of iridium hexabromide hole -2, the number of charge transfer bands and their origin are respectively. Okay, how many charge transfer bands are generated within the complex? And what will be the origin for that one we have to identify. Okay, so here iridium hexabromo -2. Iridium is the part of D7 system, cobalt, iridium, rhodium. is a part of D7 system. But here iridium is present in +4 oxidation state. Hence, the total valency electrons in the iridium becomes only 5. Okay. So here 5 electrons will be there in that iridium complex, and each bromine contributing 2 electrons. 6 bromines are there, 6 into 2, 12 electron count will be given by ligand bromine. So 12 electrons are donated by ligand, 5 electrons donated by metal, that is iridium in +4 oxidation state. Now let us see how the molecular orbital diagram is represented. So whenever we consider the complex, it is in octahedral state. Octahedral splitting will be T2G lower energy, EG of higher energy. All 5 electrons will be resided in T2G. So when 5 electrons are present here, one odd electron, 2 paired electrons will be there, and EG is empty in nature. Now, when we combine this ligand with metal, that ligand to metal charge transfer is possible. In 2 ways, ligand metal charge transfer can be observed. Ligand sigma bonded electrons can be excited into T2G orbital, and ligand sigma orbital electrons can be excited into EG orbitals as well. So that you can predict 2 kind of transitions within the molecule of low spin. So ligand sigma electrons can be excited into T2G. Ligand sigma electrons can be excited into EG orbital. The possible bands are 2, and the 2 possible transitions are observed. 2 bands, either option number 1 and 3 are correct. Ligand to metal is also correct. Sigma T2G, sigma A1G, wrong. Sigma T2G, sigma EG, this is the correct one, being it is octahedral. Transition takes place from sigma electrons of ligand into T2G of metal. Sigma electrons of ligand into EG of metal. That's why option number 3 is the right answer. Let us move on to question number 57, where the correct statement for dithionate and the dithionate anion from the following are we are having 2 different compounds, dithionite, dithionate. Let us see what will be the oxidation state of both the compounds. When we observe the structure of dithionite, it will be S double bond O, H double bond O, O minus, O minus. Double bonded oxygen resided with -2 charge. Single bonded oxygen is associated with -1 charge. Total negative charge count will be -1, -2, 3, -5, -6. Right? How many sulfurs we have to contribute? For 2 sulfurs we have to contribute. That's why 6 by 2 it will be 3. Each sulfur is associated with +3 oxidation state in dithionite. Dithionite stands for oxygen atoms are less. When we are taking dithionate, S double bond O will be there, and another S also having double bond O, and more O minus charges will be present on the sulfur. The total charge on oxygens will be -1, -3, -5, -6, -8, -10. So -10 will be the charge provided by oxygen, which is counterbalanced by +10 for 2 sulfurs, 10 by 2. So total oxidation state or charge valency of each sulfur is given by 5, right? So in this dithionate having +3, dithionate having +5 oxidation state, right? So let us see what are the statements which are correct in nature. Both have SS bond. In both we have SS bond linkage, so it is the correct option only. Both are dianionic. Here first one O minus, second one also O minus. So this is also right statement. Oxidation state of sulfur +3 and +5 respectively. +3 and +5 respectively is also right answer. Sulfur in dithionate has lone pair of electrons. Dithionate, highest oxidation state is there. That's why no lone pair of electrons will be associated with +5 oxidation state of sulfur. This is the wrong statement. Option number A, B, C will be correct, which is given by option number 1. For question number 57, option number 1 is the right answer. Let us move on to question number 58. Again, it is a part of organic chemistry. The major product formed in the following reaction. We are taking bicyclic system and having epoxide. BF3OET taken twice. Boron trifluoride in the presence of diethyl ether. So what will be the product? So that will be explained by drawing its mechanism. Whenever boron trifluoride is treated, being it is electron deficient Lewis acid, it takes the electrons from the oxygen of epoxide. Three-membered ring with lone pair of electrons highly sterically strained. That's why immediately ring opening reaction will be. How it will be? Oxygen is donating electrons to BF3 and oxonium ion will be generated. Oxygen within the three-membered ring with a lone pair of electrons and a carrying positive charge is highly unfavored. Hence, immediate ring opening reaction is possible and hydrogen will be eliminated. Subsequent carbon-carbon double bond is generated. Now, it can be written in the form of, it can be further subjected to hydrolysis so that it is converted into OH. OH when present, you can say this is enolic form. When enolic form is there, we can tautomerize this into ketonic form. So 2-methyl in the adjacent position towards the VR is highly sterically strained. That's why stereochemistry can be slightly variated so that methyl is going back in order to get the sterically unhindered condition. So that compound will be this, what we are expecting by using this reaction, right? So option number 1 is the exact answer for this one. By writing mechanism, we can clearly understand this. So now let us move on to question number 59. The linear variation method using two orthogonal basis functions, two roots obtained are epsilon 0, epsilon 1. The condition is epsilon 0 is smaller than epsilon 1. The correct relation of these are exact ground and first excited state energies E1 and E0 and E1 respectively are. So they gave already relation between epsilon 0 and epsilon 1, right? Orthogonal basis functions epsilon 0 and epsilon 1, always epsilon 1 is greater than epsilon 0. And what they are asking is, so their relation with energy state 0 and energy state of excited. So we have to deduce this relation. In order to get that, energy of trial wave function is always greater than exact energy. That means epsilon value is always greater than exact energy E. Epsilon will be greater than energy E. That simply says ground state energy of trial wave function is greater than ground state exact energy. Excited state trial wave function energy is greater than excited state exact energy. So epsilon naught is greater than E naught. Epsilon 1 is greater R equals to E1. The correct option will be option number 4. Very simple relation. So this is a part of physical chemistry. In the next, last question in the series by this entire part C will be completed. Is a part of organic chemistry. So here it will be dithionate. So this dithionate compound was taken and is treated with two different alkyl halides. Two different alkyl halides were treated, and what will be the products with these two and what will be A and B compounds obtained. Conditions are exactly same, only the difference is alkyl halide. Butyl lithium base will be added, minus 78 degrees thermal conditions also same, and hydrolysis with the mercury dichloride will be same. Only the difference is alkyl halide. In first case we have secondary halo. In second case we have primary halo. Let us see what will be the product of A and B. That can be clearly explained by mechanism. When we are taking this compound, so under strong basic conditions, there is a formation of carbene ion, being it is the active methylene carbon. It readily generates carbene ion which is highly stabilized by adjacent heteroatoms. Now, it involving SN1 type of mechanism and it will be bonded to this carbocation here, so that we will get so this product. Subsequent hydrolysis with mercury dichloride and H2O. Always mercury dichloride and H2O used to give carbonyl compounds upon hydrolysis. So here the bond between this sulfur carbon will be cleaved and it is converted. This carbon linked in this ring will be converted into C double bond. That means aldehyde will be generated in the terminal center, right? This is of first kind, that means B product. Now let us deduce A product. In order to get A product, there is a formation of carbene ion. This is exactly similar under basic conditions. Now it is treated with this halo compound where SN2 type of mechanism, not exactly SN2, but it is a kind of SN2 type of mechanism. So negative charge chloro is not a better leaving group when compared to bromo, and being it is secondary, it will not be departed easily. That's the reason why negative charge will be attached from the back end, so that ring opening reaction is possible here. After ring opening, oxide will be generated. This oxide will involved in ring cyclization and subsequent chloride removal. We will get the product of this epoxide, which is containing terminal aldehyde, but this epoxide is also substituted by one of the methyl. Let us see. A should contains one methyl on epoxide. Here methyl is there on epoxide. Here it is not there. 2 is not correct answer. 3 is also not correct. 4 is possible because here we have methyl substitution on epoxide. Either option number 1 or 4 may be correct. Now let us see option number B. In option number B, epoxide should be there. Here epoxide is not there. So epoxide side reaction is possible in this. This is not correct. Option number 1 is satisfying this entire chemical reaction. So for this question number 60, option number 1 is the right answer. Option number 1 is the correct answer. So we completed entire part C of December 2019 chemical science CSIR NET GRF question paper. So hope it will be very much helpful for your preparation. Thank you very much. Thanks a lot.